The purpose of this experiment is to determine the empirical formula of a compound formed between copper and sulfur quantitatively. Also, through observations, verify that a reaction has occurred and a compound is formed. Safety glasses or goggles, lab coat or apron, gloves, and closed-toed shoes are required. Long hair should be in a ponytail to keep away from Bunsen burner. All heating of the copper and sulfur mixtures will be carried out in the hood, where there are iron rings, clay triangles, ring stands, and Bunsen burners set up for use. Cleaning the crucible. Using a ring stand, iron ring, clay triangle, and Bunsen burner, set it up to clean the crucible. There should be about 5 centimeters from the bottom of the ring to the top of the Bunsen burner. Place the crucible to be cleaned in the clay triangle. Crucible tongs will be needed to remove your crucible after cleaning. Adjust the burner to a very hot flame. The tip of the inner cone of the flame should touch the bottom of your crucible. Once the bottom of the crucible turns red-orange, heat for 2 more minutes. Remove crucible and place it on wire gauze or your evaporating dish to cool. You will use the dish to carry the crucible to the balance. The countertop can take the heat, but it leaves a circular mark. Remember to turn off the Bunsen burner. While the crucible is cooling, write your description of the copper wire and the sulfur powder that will react. Next, make a flat coil of copper, demonstrating the malleability of the wire that will fit in the bottom of the crucible. In the balance room, remember to fill out the log sheet. When the crucible has cooled, weigh the empty crucible to the nearest 0.0001 grams on the analytical balance. Next, add copper wire to the crucible and weigh again to the nearest 0.0001 gram. Fill the crucible halfway to cover the copper with sulfur powder. Excess sulfur is added to be certain that all copper reacts. X copper plus Y sulfur yields copper X, sulfur Y. X and Y will be determined from the data. Start with the cool flame, a single blue cone, to heat the 2 elements. Using your tongs, place crucible and clay triangle in the hood and pull door closed, which will straighten out the flame and keep the sulfur dioxide out of the classroom. Heat using the cool flame until you can see the copper wire. Increase the heat. When the bottom of the crucible turns orange, heat for 3 minutes at the high heat. Remove the crucible from the heat and place it in your evaporating dish, taking care to not touch the bottom of the dish. Remember to turn off the Bunsen burner if you are the last student to use it. Otherwise, leave it on for the next student. Return to your bench with the crucible. You may let it cool in the evaporating dish or place it in your wire gauze. While you are waiting for the crucible to cool, calculate the moles of copper. Once cooled, weigh the crucible plus product to 0.0001 grams using the same analytical balance. Next, calculate the moles of sulfur that reacted with the copper. Your collected data should be as follows. Now, with this information, the empirical formula may be calculated to determine the percent error. Percent error in copper subscripts equals the absolute value of 2 minus experimental value divided by 2 times 100%. If the copper subscript is high, the crucible plus product should be reweighed because it might have not cooled sufficiently. If the copper subscript is low, Heat the crucible and contents for 30 seconds to a minute on high heat. Cool and reweigh. If the percent error is less than 10%, it is not necessary to add sulfur and reheat. When complete, perform the brittleness test on the product. Take a metal spatula and try to break the product. After completing the test, put the product in the waste jar. Your observations should include the following: description of reactants, description of reaction, description of product, and the result of the brittleness test.